Welcome everybody to ePathshala. I am Soumik of the Department of Geological Sciences, Jadavpur University. Today I am going to discuss about the shallow marine environments, the sediments deposited therein, their characterization, vertical succession and types of different shelves. My lecture outline will be made up of after a brief introduction, I will go to the type of sediments found within a shallow marine environments. Then I will characterize shallow marine environments on basis of different sub environments like shore face, outer shore face, offshore, and then the vertical succession expected in a shallow marine environment. Before going to the characterization of shallow marine environments, we have first to establish how much area it covers. According to the classical cross section of ocean floor is subdivided into several zones. Littoral is the zone which is marginal, then comes neritic zone up to continental shelf, then continental slope is radial zone and abyssal plain is represented by abyssal zone. Now, the marine processes operate from neritic to abyssal zone. Littoral zone is the zone where both the continental and marine processes operate. Marine environment encompasses from neritic to abyssal zone. Now, within the marine environment, can be subdivided into two parts, shallow marine environment and deep marine environment. Shallow marine environment encompasses up to the shelf break, that is the neritic zone. So, shallow marine environment basically includes the continental shelves, inner portion of which is wave dominated and lower portion or outer portion is current dominated. So, shallow marine environments are basically restricted within the shelves of pericontinental seas persisting in present day time. They are also encountered in Precambrian epicontinental seas where there is no shelf slope profile. So, shallow marine environments basically represent shelves of modern day pericontinental seas. They are also present in Precambrian epicontinental seas which are shallow seas without the shelf slope profile. Now, coming to the sediments encountered within the shallow marine environment. Marine realm basically receives four types of sediments: terrigenous, biogenous, hydrogenous and cosmogenous. Among these four, terrigenous and biogenous made bulk of the sediments in total marine realm. Within shallow marine realm, terrigenous sediments made up the bulk of the sediments and supported by biogenous ones. Hydrogenous sediments are totally absent in shallow seas and cosmogenous sediments are usually very insignificant. Shelves receive the bulk of their sediment from the continental margin as terrigenous. Shoreline turbulence carried the finer particles further seaward and deposited them in deeper waters. So, the overall grain size reduction as we go towards deeper waters is a common phenomena. Under idealized condition, along with the energy condition, grain size also decreases as we go away from the shoreline towards deeper water. But generally, such ideal conditions are not maintained due to the reworking of tide and oceanic currents as well as the past fluctuations of the sea level, which entrap some remnant sediments of past into the current shallow marine environment. Now, other important shelf sediments are biogenous, preferably in the form of carbonates. They typically develop where the sediment supply, that is terrigenous supply, is low. They usually form reefs in warm waters. Reefs are wave resistant organic buildups which develop in warm waters where terrigenous supply is low. Formation of reefs transform the continental shelf into a rimmed platform from its original ramp origin. These carbonate rim platforms are discussed in other areas. We will mainly concentrate on the terrigenous shallow marine environments. Now, to the characterization of shallow marine realm. Shallow marine realms are divided into three sub-environments depending upon the extent of wave agitation. Now, see this picture here, This zone is within the shallow marine realm. This up to this shelf break. This zone is enlarged here and divided into upper shore face, lower shore face and offshore depending upon the extent of wave agitation. Now, it is based on this wave base. What is wave base? Wave base is the extent at which the wave first touches the sea floor. So, it varies for fair weather and storm weather. Now, upper shore face is characterized as the area between the mean low water and fair weather wave base. Lower shore face is between fair weather and storm weather wave base, and offshore is the area where offshore is the area below the wave base up to the shelf break. Now, this upper shore face is characterized by wave features and wave generated current features. Lower shore face, they receive mostly silty material deposited from suspension fallout with intervention of storms. Only storm waves can penetrate here, no fair weather wave can penetrate up to this depth. So, there are intercalation of sandstone beds which show similar hummock and swell structures as in case of storms, but they are rare here. Storm evidences of storms are much more in this zone, but they are represented by mostly swelly cross-strata. Hummocks usually gets decapped and not preserved in this zone. On the other hand, offshore region is chiefly dominated by suspension fallouts. No sandstone bearing wave features are present here. Now, modern day shelves can be categorized into broad 4 divisions: wave or storm dominated shelves, ocean current dominated shelves, tide dominated shelves and mud dominated shelves. Wave or storm dominated shelves make the bulk of them, about 80% of the total modern shelves. It is dominated by normal sedimentation frequently interrupted by storm surges. Normal sedimentation is represented by wave agitated sandstones. Wave induced current features are quite common, represented by tabular cross strata, trough cross strata and transforming itself into ripple lamination towards the margin. This normal sedimentation usually get frequented by storm surges. Storm beds are characterized by scouring at the base. They are hummocky or swelly cross stratified. Usually towards the shore, hummocks gets decapped and swells gets preserved. These storm beds are finding upward bodies started with erosion at the base and following sedimentation will be massive, followed by hummocky or swelly cross strata and then ripple lamination. It ends with a ripple lamination. Lag deposits made up of shell debris are quite common. Tempest tides are product of storm which are common in comparatively deeper water, that is within offshore, which represent the total succession of a storm deposit started with the scoured base, erosional base, followed by massive deposits, then hummock and swelly deposits, followed by ripple laminated sand and finally by mud. These kind of tempest tides are quite common in deeper water of this kind of shelves. Tide dominated shelves covers up about 17% of the modern day shelves. They are found in macrotidal areas where the tidal intensity is high. They used to form in shallower shelves. The main criteria being the slope must be less, otherwise the wave will not be broken far away from the land and tide can dominate. In those areas, tide can transport the material stirred up by the storm surges and deposit them perpendicular to the shore, forming different kinds of structures. The resultant bed form ranges from small ripples to large dunes depending upon the tidal intensity as well as the sediment supply rate. But all these bed forms are oriented parallel to the mean tide or ebb direction, whichever may be the strong, and consequently forming high angular relationship with the coastline. In areas with high sediment supply, tide dominated shelves used to show huge sand flats. Tide is an important process in marine realm but usually they get subdued by the existence of waves. Now, according to tidal intensity, coastlines can be subdivided into three types: microtidal, mesotidal and macrotidal. Among these, macrotidal coasts experience maximum tidal intensity. So, tide dominated shelves are usually developed in macrotidal setting, where the tidal intensity is high. In these regions, tidal currents used to redeposit sediment along to tide or ebb current direction, that is perpendicular to the shoreline. Tidal intensity, if high, can carry sediment as high as sand to gravel size material. But usually they are not capable of resuspended them after their initial deposition. So, storm surges are needed, which are frequent enough in an open marine condition. Those storm surges lift up the particles and those particles get redistributed by tidal current. Depending upon the current intensity, a series of structures can be formed ranging from small ripples to large dunes. Tidal intensity and the amount of sediment supply is the controlling factor. Now, tide will be dominant in areas where the slope of the shelf is less, because in that condition waves will be broken far away from the shoreline. It allows tide to be dominant in those areas. So, usually tide dominated shelves are shallower in nature than any other kind of shelves. Now, look at this picture. This picture is showing the general distribution of bed forms in a tide dominated shelves. This is the general model. Land is towards bottom, that is depth of water increases northward, topward. You can see that most of the bed forms are shore perpendicularly oriented, that is according to the direction of tide and ebb. These kind of crescentic dunes followed these ridges and then sand flat. This area is mostly sandy, that is within the upper shore face, then this area is lower shore face and this area is mud dominated offshore region. Now, the size of bed forms increases towards land up to a certain level, that is up to the extent of shallow marine environment. As the tidal intensity also increases in this direction, tidal intensity increases landward after it first touches the surface. Now, this is the model. These two diagrams is showing the importance of the sand supply. This is a low sand supply model and this is high sand supply model. In this case, produced bed forms are rare. They are very less in number, but they maintain the similar disposition, that is in offshore regions smaller furrows, then followed by sand ribbons, then large sand waves, small sand waves and so on as found here. But the frequency is less, much less in case of low sand supply model. On the other hand, if the sand supply is high, then the frequency would be much more, as high as they often amalgamate together to produce a sand bank. These shore perpendicularly oriented sand banks are huge structures underwater, but often can get exposed during low water stage. These sand banks are mainly found in the region of These sand banks are mainly found in the region of lower shore face to upper shore face. In this region, shore parallelly oriented large sand waves are found, and in lower shore face region mainly this sand bank develop with amalgamation of huge sand waves. And the offshore region, this area is characterized by sand ribbons instead of furrows and gravels. So, you can see that the total phenomena shifts seawards if the sediment supply is higher compared to this low sand supply model or even general model. In this case, this offshore region is characterized by furrow structures only. Here we are getting The depth is same, but here we are getting sand ribbons. So, the total phenomena, that is the disposition of this bed form, shifted seaward if the sand supply is high. So, tidal intensity as well as sand supply both cumulatively control the disposition of these tide dominated shelves. Now, the next important category is ocean current dominated shelves. These made up a meager 3% of the total shelves of modern day. Because ocean bottom current dominated shelves required both wave and tide must be subdued. In areas where the slope of shelf is high, that is the shelf is high sloping shelf, in those areas only ocean bottom current dominated shelves can be formed. Further, the enhancement of ocean bottom current is also required, but these kind of shelves are usually very hard to distinguish from a tide dominated shelf. The characteristic products, that is bed forms produced by these kind of shelves, are similar to that of tidal currents. Only they are oriented not perpendicular to the shorelines, but along the shoreline, that is at an oblique angle to the shoreline. So, they are very hard to distinguish from tide dominated shelves. Mud dominated shelves on the other hand are very rare in occurrence. They are only encountered near the confluence of a river. The river also need to be a large one, otherwise the amount of sediment carried to the ocean by the river will not be sufficient enough to transform the total shelf into a muddy one. In these cases only mud dominated shelves can be produced, that is in case of a huge river debouching in a sea, on that area near the confluence only mud dominated shelves can be formed, and they characteristically possess suspension fallout deposits as in case of mud, because no bed load movement can take place in muddy environment. So, they are almost devoid of any other structures than planal laminae. Storm beds rare, very rare in those areas, because muds are very hard to get eroded after once it got deposited. So, these kind of shelves are very rare in nature. Mud dominated shelves are very rare in occurrence and only observed in areas near to river confluence. The river must be a large one to supply sufficient amount of finer materials. Now, coming to the vertical succession. The sedimentary succession of a shallow marine realm is dependent on the rate of sea level change. It can be progradational, that is coarsening upward, as well as retrogradational, that is fining upward. Progradation results from the seaward shifting of the facies belt, that is the shallower water facies gets deposited over the deeper water facies, and consequently we get a shallowing upward or coarsening upward succession. Now, coming to the classification of modern day shelves. Modern day shelves can be classified into 4 categories: wave or storm dominated shelves, tide dominated shelves, ocean current dominated shelves, and mud dominated shelves. Among them, wave or storm dominated shelves account for the lion's share. This is the commonest variety, and shelves are generally characterized by these kind of sediments. Now, in modern day open wave or storm dominated shelves, upper shore face is characterized by sandy sediments, followed by silty lower shore face and muddy offshore sediments. These are the general classification of sediments. These divisions are mainly based upon wave basis, as I explained earlier. So, area within the upper shore face is characterized by dominant wave features and wave generated current features. The sediment deposited in this area is characterized by ripple laminated to trough cross stratified to tabular cross stratified sediments. This normal sedimentation is often frequented by the storm surges. These storm surges erode the already deposited sediment and resuspend it. Deposition from these resuspended particles used to produce hummocks. These kind of hummock swell structures are very much common. They often amalgamate towards the shoreline. Hummocks usually are decapped in this area. As we go away from the shoreline, hummocks are generally found in more abundance than the swells. In the near shore area, swells are more dominant ones. Basically, in this area, normal sediments usually get eroded out. Only storm surges, evidences of storms are found in this area. Now, tempest tides are important in deeper waters, that is beyond the upper shore face. They form during storm events and exhibit a characteristic facies association from an erosional basal surface with shoal marks to a sandy unit, usually massive, followed by hummocky cross stratification overlain by wave ripple sand. Finally, mud gets deposited. These tempest tides erode the background sediments of the deeper water, that is beyond the upper shore face. In case of lower shore face, these normal sedimentation is usually silty, but in case of offshore, muds get deposited here, and these kind of coarse grained storm beds represented by coarse grained tempest tides are usually found, eroding these background sediments. Symmetric ripples as shown here are common at the top and shoal marks at the bottom. In case of fine grained storm beds, the whole succession of tempest tides are more developed. These hummock and soil cross stratifications that gets developed, usually these kind of fine grained storm beds which are devoid of any coarse materials. This is a figure of typical tempest tide. These are two tempest tides. These are background sediments, covered bases, covering is here. This portion is massive, followed by hummocky cross stratification and then followed by little bit of mud deposit. Then again background sedimentation resumes and again intervened by another tempest tides. This kind of alternating nature is common in case of lower shore face and offshore. In offshore, the frequency of tempest tides are usually less. Now, bottom sediments stripped up by such storm generated undercurrent can form turbidity current in further deeper water, that is within the offshore or even in deeper waters, that is within the abyssal plain, which produce turbidity deposits classically represented as Bauma sequence. To summarize, it can be said that the shallow marine environment includes the neritic zone of oceanic section. It extends from the shelf break up to the area permanently submerged under water. It is observed at the continental shelves of pericratonic seas of modern time and within the epicratonic seas of Precambrian time. Now, the sediment grain size decreases away from the shore up to the continental shelf margin. Upper shore face is characterized by sandy sediments and offshore is by muddy sediment. This division upper shore face, lower shore face and offshore is primarily based on extent of wave agitation. Upper shore face is above the fair weather wave base, lower shore face within fair and storm weather wave base and offshore is below the storm weather wave base. Now, primary structures observed are mostly ripple lamination and different types of cross stratification produced by wave generated currents. These are the normal sedimentary products and it is frequented by storm surges which are characterized by hummocky or swelly cross strata. Amount of hummock increase towards the lower shore face as in upper shore face hummocks usually get decapped. In this area swells will be dominated. Storm beds are usually amalgamated. Tempest tides are storm units represented in the deeper portions as in offshore or lower shore face. They are characterized by an erosional surface followed by hummocky cross stratification, ripple lamination and finally by mud deposits. These kind of tempest tides are quite common in lower shore face and decreases in offshore. Now, modern day shelves can be classified into 4 categories dominated by wave or storm dominated shelves. These are typical products. Others are tide dominated shelves where tidal current produce bed forms oriented perpendicular to the shoreline, that is parallel to the tide or wave velocity. The character of these tidal shelves are typical and very much similar to the oceanic bottom current dominated shelves. These are the third dominant variety, but is very less in amount. Other variety is mud dominated, which are almost absent in nature. In vertical succession, these kind of shallow marine environments can produce both coarsening upward as well as fining upward successions depending upon the nature of sea level changes. Thank you.